All right, so let's work this problem. Again, you have to find all the forces in the whole truss system. And we have an actual force applied here, 100 kip force. You can see all the dimensions. Oh, I want to note this because it came up earlier. Sometimes these dimensions, the author might write 2 at 20. So that means 2. That means there's 2 equal lengths, and each are 20 feet. So you see that kind of notation too, for especially if the dimensions are uniform, and especially in trusses and bridges, where you might have 100 of these things. So you can just easily write 100 at 20, and you know that every spacing between the nodes along the bottom chord is 20 feet. So I don't want that to throw you for me. Okay, let's look at this thing. Are there any zero force members?
Yes.
Let's just go through them. Case 1. Remember case 1? What was case 1? There's 2 elements connected, no load. So I see A has 1, 2 elements connected. Hey! No load. So what does that mean? That means AB and AE under this loading case are 0. What about here at C? There's 2 forces connected. Oops, there's a load, so I can't do that. Is there a case 2? Now this looks like case 2 at E. See, there's 3 elements. 2 are collinear, but what's applied at E? A reaction, which is force. So that's not a case 2. So right off the bat, I can just start by saying, oh, ho, 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 these are zero force members. 0. 0. And what I like to do is right underneath it, I like to write that I know I am identifying zero force members. And I'll go ahead and write them out. So I'll say that the force in AB is 0 and the force in AE is 0. So I got 2 of my unknowns right off the bat. Now, of course, if you misidentify those, you're in big trouble, because these incorrect results are going to percolate all the way through your solution. So be confident. If you're not confident, just go some moments at A. I mean, go do a joint at A and see what you get. You'll find out that this is true. So if you feel you're not comfortable with that, well, you're going to have to go there anyway. That's a good place to start. Even if there were a load there, that's a good place to start anyway. So just go ahead and do it anyway. And you'll find out that that's true. So with those 2 out of the running, then we only have 1, 2, 3, 4, 5 unknowns. So where's a good place to start? Could we go to C? Sure. We don't even need reactions yet. We could just go right to C. So we could get 2 more. We could get 4 of the 7 things before we ever have to worry about the reactions. Which is kind of interesting. Once you found those 2, you could actually go to B and find these 2 diagonals. So the only one you would be out would be DE, and then you would need to either go to D or E, and then you're going to need the reactions. So either way, eventually we're going to need them. So let's just go ahead and get them out of the way to start. So kind of like we've done previously, let's go ahead and find our reaction. So E is a pin, so I'll have a Y and an X reaction at E. D is a roller, so we'll have a reaction in the Y direction there. And based upon this free body, I'm going to come over here and write those 3 equations. So up to now, our strategy has been pretty much to go to the pin in some moments. I think that's still going to work pretty well here. So let's do that first. So I will assume right-hand rule for my sign convention for my moments, and we'll sum them about A and make sure they're equal to 0. So I meant E, not A. Sorry. I wrote A. I said A. I meant E. Me. N-E. Me. So something about me, this force applied is going to create positive or negative moment about E. Negative. So we got a negative moment. The force is 100 kips. And the distance from E, the line of action through E, to F's line of action is this height, which is 30 feet. And then I've got my reaction at D, which I assume is acting up. What kind of moment does that create about E? Positive. So the force would be EY, whatever that is, and then the distance between E and D is 20. So it looks like EY is going to be positive, and it's going to be 300 divided by 20, 1/5, I don't know, something. 150? Is that right? I said 300. I meant 3,000. I think it's 150, isn't it? That'll be kips. So now we can sum forces in the y direction. And what do we have for that? Well, EY and DY are both up, so those will be positive in my accounting.
Wouldn't that be EY?
What did I say?
EY?
Oh, I messed that all up. You're right. This should be D, and this should be D. Thank you. I've got some land in Florida you guys want to buy. Just see if you're paying attention. It's real cheap. I guarantee it'll be worth a lot more next year than it is now. I guarantee it. The probability is high. No, that's a bad joke. Okay, so up and up, and that's it. That's it. There's nothing else in the y direction, is there? So EY is equal to minus DY, and that's equal to minus 150. So again, if you're thinking about it pivoting here and you're pulling it to the right, you'd expect dy to push it back up. And then if you think about looking a moment about D, I'm pulling to the right, you better expect EY to be pulling down. So those signs kind of make sense, even though my writing kind of led you astray there for a bit. Okay, so now we have all the, we got one more, I forgot. We've got some forces in the x direction. In this case, we have EX to the right, so that's positive. And our load is to the right, that's also positive. So that should not be a hard one to solve. It looks like EX is equal to minus 100 kips. And again, that makes sense too. If the whole structure is being pulled to the right by the load, you expect the one horizontal reaction to push to the left to balance it. Okay, so now we have lots of choices. We can go to C. We could go to E. Right now we can't go to D because there's 1, 2, 3 unknowns. And we can't go to B. There's 1, 2, 3 unknowns. So we'll either go to C or E. Which one do you guys want to go to? C. What do we say? C? C? So let's go to joint C. Now, the one advantage of going to joint C is you should be able to find these two reactions, and they won't include any of your previous calculations. If you did go to E, both your results are going to be directly dependent to EX and EY. So if you had made a mistake, that's going to show right up immediately. So here's a chance to get some independent calculations for some of your variables. So here is our joint at E. Here's the applied load, 100 kips. Here is the reaction in CD, in tension. And here is the tension reaction in bar BC. Now we just need to know the geometry of this element, the direction. So we need to know the direction between C and D, or C and B. So the slope of that line would be a rise of 15 over a run of 20. Hey, if you divide that by 5, you get the famous 3, 4, 5 triangle. We love 3, 4, 5s. They're very cool calculation-wise. 3, 4. So the hypotenuse is 5. Your author likes those a lot. He just hides them by multiplying them by 5 or some other number. So look for those multiples. You should see a lot of 3, 4, 5 triangles. Now, what equation should we write first? Should we sum forces in the y direction first? No, because both our forces have y components, so that'd be a poor choice. But summing forces in the x direction is a good choice. You chose wisely. Oh, I forgot to denote that that's 100 kips. So summing forces in the x direction, we have our 100 kip to the right, that's positive. And force BC, the x component, is negative. And the horizontal component would be 4 or 4/5. So there's the horizontal component of BC balanced by the applied 100 kip force. So the force in BC looks to be positive and looks to be 125. Does it make sense that BC is in tension? Well, don't let these guys distract you. They're 0, so I'm just going to kind of cover them up. So you got this weird kind of trapezoidal shape looking thing. If I pull on it right here, I imagine this whole outer thing will go into what? Tension. And probably this will go into compression, and probably this will go into compression. I'm not so confident about this one, but I have a feeling, I don't know what it's going to do. This might even go into tension. I'm not sure about these two. Maybe go into tension. Maybe. We'll just have to see. But right now I feel pretty good that BC and BE will probably be in tension, and we got that. So that feels good. So now that I have that, I can now go back and sum forces in the y direction. And what do we get? Well, I've got CD acting down, and I've got BC acting down, so they're both going to be negative. So I'll start with that. So I've got minus the force in CD, and then the y component of BC, which is 3/5. So 3/5 of BC, and it's acting down. So it looks like CD is going to be negative. And what's it going to be? 75. That seems reasonable. And we already talked about CD being in compression, so I think that looks okay. So I'll go ahead and put a little squiggle there, and a little squiggle there. We've got that. So we're down to just this little core triangular set. Now, is there any joint that's out of play right now? No. We can go to B, right? Because there's only 1, 2 unknowns. Of course, you can. That might be a good place to go. We can go to D because there's only 2 unknowns, and we can go to E because there's only 2 unknowns. For my money, I like E because my two forces are, one is all in the y direction and one is all in the x direction. That's going to be a pretty easy equation to solve. So let's do that. So here is joint E. So I have my reaction, EY, and I found EY to be negative 150, which is down. And I have a value for EX, which is 100. It was negative, so it's this way. So those are my reactions. And then I'm going to assume a tension force in DE and a tension force in BE. I don't have to worry about including the force AE because it's 0, so it's not going to affect anything. I think you can see that's going to be a pretty easy one to solve. The order is not important. You sum forces in the X, you're going to get DE. You sum forces in the Y, you're going to get BE. It's probably going to take us longer to write the equations down. You can probably already see the solution. But if I do sum forces in the Y direction with up as positive, I have BE up, and I have minus 150 acting down, so the force in BE is 150. And then I'm going to solve for DE by summing forces in the X direction. Again, in equilibrium, I'm going to assume positives to the right. So I've got my force in DE to the right. And of course, I've got my negative 100 kips to the left. So that's negative. So it looks like the force in DE is 100. So we talked before about BE being on this outer chord, probably being in tension, and that's what we got. We got a tension. The one that's not maybe as easily seen is DE. It's in tension. And I think as you try to pull the whole structure to the right, D must slightly drift to the right and put that bottom chord into tension too. So let's see. Have we finished? We got that one, and we got that one. So the only thing left is that diagonal. And you really have whether you want to go to D or you want to go to B. I don't know which one I prefer. I probably like D better. Simply because this one's all X, this one's all Y. I only have to worry about one set of components. If I go to B, I've got two forces I have to worry about components. It may just be a little bit more work. So I'm going to go to D. So I flip this over, and let's do the joint at D. So here is D. Now I do have a reaction there, dy. Let's see, dy was minus 150, right? Is that right? No, dy was positive 150. And then, of course, I have tension in DE and tension in force CD, and I assume tension in force BD. And what's the slope of that? What's the direction of that? Yeah, you see it's 15 high, run of 20, so that's going to be a 3-4. Again, 3 high, 4 long, and a 5. Let's not forget that we already know CD, right? And we already know DE. So the only thing we're missing is the diagonal. I don't know which one would be best. If you sum forces in the X, you just have this X component and that one. That might be the smallest calculation. If you sum in Y, you've got this and the Y and another 150. So maybe X is the easiest of the two to do. So that's the one I'll do. So I'll assume to the right is positive, and we will sum forces in the X direction. And what do I've got? Well, I've got force FD is to the left, and the X component of BD is also to the left. That's negative, and that X component is going to be 4/5 of BD. So remember, I'm trying to solve for BD. So it looks like BD is going to be, I don't know what FD is. What do we get for FD? ED, sorry. I got positive 100, right? So this is positive 100. So it looks like this is going to be negative. Looks like it's going to be negative 125. What you guys got?
Yep.
So the diagonal is in compression. Hey, we did better on that one. That was 20 minutes. Now, I know you can go faster if I'm not talking to you and distracting you and telling stories and coughing and sneezing and talking about my head cold. Any other questions about this one? I think it's more doable, moving towards one that we could actually do one of these days.